Okay, so let's see where we left off. We left off at number 4, right? We went through the steps. We talk about, excuse me. We talk about that, how we're gonna work on these kind of questions. First, we determine the domain. And then we're gonna solve the equation. And then we check the answer. So there's 3 major steps. There's 3 major steps, right? On these 3 major steps, which covers domain, operation, and the check answer. And checking answer, there's 2 small parts, which is there's one domain check and there's one equation check. So domain check and equation check. Now, we were at number 4, right? Number 4. Let's try number 5. Let's try number 5. Okay. Number 5, we have log base 5 of x plus 1 minus log base 5 x minus 1. And that difference is equals to 1. Okay, so how do we solve this kind of equation? Okay. All right. So in this case, we need to combine them into one logarithm, because only when we have one logarithm could we apply the definition. So we have a 1 logarithm base 5 subtracting the other logarithm base 5. How do we make it one single logarithm? Which rule do we apply? Product rule, quotient, product rule, quotient rule, power rule, which one? Do we still remember those rules? Chat, quotient rule, very good. Okay, you're right. So we would apply quotient rule. And then we got x plus 1 divided by x minus 1. On the other side is equals to 1. Okay, so let me make the fonts a little bit larger so you can see the subtraction sign. And then what do we do? Then we can use definition. Okay, by definition, this is the omega. Oh, we haven't done the domain yet. Wait a second. Yeah, we need to do the domain, okay? So this is going to be equals to 5 to the power of 1. Okay, so I'm going to insert the domain here. The domain consideration. Okay, my bad. Totally my bad. Okay, so we're gonna come back here because I want to make a point that domain is very important. Okay, domain is very important. And then the solving part comes next. I apologize. Okay. On the domain part, we need to guarantee that x plus 1 must be larger than 0. And the keyword must be and. X minus 1 must be larger than 0. And from the first inequality, we get x equals to x larger than -1. And the other one would be x is larger than 1. Combine these two, the final answer is, what is the final answer? What domain? That will be x greater than 1, right? That will be greater than 1. Got it? Yeah? Do we understand why? The reason is very similar to what we talked about last time, right? We need to be greater than negative one. And we also need to be greater than positive one. But we have to make this happen for both, right? So on the one hand, we need it to be greater than negative one, which is from here, right? Greater than negative one, and greater than positive one. So from here, right? And to make them true, both true, well, and A and B is true if both are, only if both are true. Therefore, the final answer has to be just this part. Make sense? Okay, so that's the domain. That's the domain must be greater than one. Everything we do is operated on this, in the domain. Everything we do, we operate in the domain. So that's why at the end, we need to have a domain check. Okay, so now let's come back. Okay, we were here. We apply quotient rule, and then we solve for x. Okay, and then how do we solve for x? Because x is greater than 1, so denominator is not 0, so we can multiply x minus 1 on both sides. Okay, so we had x plus 1 equals to 5 times x minus 1. We can do this because we operated in the domain, which guarantees that x is greater than 1. X greater than 1, therefore, x minus 1 is not equal to 0, right? So then we can multiply both sides by x minus 1. Do you guys understand that argument? Do you guys hear my argument? Yes? Should I write it down? You guys follow me? Right? So I'm going to put the arguments here. Okay. X is larger than 1. Thus, x minus 1. Thus, x minus 1 is not equal to 0. Okay. And then we can multiply both sides by x minus 1. And this is to use principle number 4. This is to use principle number 4. Okay. Do we still remember what's principle number 4? Do we still remember what's principle number 4? If A is the same as B, then A times C is B times C, provided C is not 0, right? That principle. Okay, but anyway, without further ado, so then the next step. Okay, so let me scoot over a little bit. Okay, so I have more space to write it on the right. Okay, so now we have, oops, these are shifted, so just clear them. Okay, so now we have x plus 1 equals to 5x minus 5. Okay, 5x minus 5. And bring all the x's together and bring the constant together. So we end up with 6. Okay, 6 equals to 4x. So in the end, what does x equal to? X equals to 6 over 4, which is 3/2. 3/2. And then we check our answer. Okay, domain check. Okay, domain check. Okay. Is 3/2 larger than 1? Yes, 3/2 is larger than 1. Okay, so x equals to 3/2. It's larger than 1. But this is not enough reason to say it is a solution, right? So we have to bring it back to the original equation. The original equation is right here. Okay, so we're going to check the left-hand side to see if that is equal to the right-hand side. Okay, left, right. Okay. Log base 5. Three half. Okay, 3/2 replaces x plus 1 minus log base 5. 3/2 minus 1 equals to log base 5. 3/2 plus 1, that's 5/2. A 5/2, right? Minus log base 5. 3/2 minus 1, that's half. Okay, apply quotient rule. We get log base 5 of 5 minus log base 5. We apply quotient rule right here. Minus, okay, there's a log base 5, 1/2. So if we apply quotient rule, that's going to be log base 5 of 1 minus log base 5 of 2. You guys follow me? This is not the only way to do it, but I'm doing by expansion. Okay, you can use a quotient rule the other way. Okay, you can use a quotient rule the other way. Okay, which is make that into one logarithm. You can do that too. Okay, and I will show you shortly how you would do that. Okay, and then we have these two parts. This guy equals to 1, right? So it's just 1 minus log base 5 of 2. And log base 5 of 1 is 0. So negative makes positive, right? Negative, that makes positive. Okay, and these two make 0. So we have it equals to what? 1. Okay. Combine, we get 3/2, 5/2, 1/2. Apply quotient rule to each one, and we operate, and we get 1. Okay, and then we can say x equals to half is a solution to the equation. Which equals to 1. Okay. On the other hand, okay, so when we check from here, you could make it into a quotient like this. Okay, if you want. But I feel this is this will end up with a complex fraction. Okay, so it's a 5/2 over 1/2. But if you're proficient with it, that's not a problem. Okay, if you're proficient with it, and actually you should be proficient with it, but at least you have 2 ways to check if you get the right answer, right? So log base 5 5 over 2, 1/2, and the 2 and 2 reduces, you have a 5, so that equals to 1 as well. Okay, so you can do that way too, certainly, okay? So we're not limited just to one way to do it. Okay, so now it's your turn. Okay, so we're done product rule, quotient rule. In solving logarithm equations, the 3 major steps. So next, I want you guys to try number 6, number 7, number 8. 6, 7, 8. Are you ready? Paper, pencil. 6, 7, 8. Your turn. 6, 7, 8. 6, we have ln 3x minus 10 equals to 2, if that is true. Okay, and 7, ln x squared minus 1 is equals to 2. Number 8, log base 3, 2 minus x is equals to 3. Okay, I'm going to give you a couple minutes to work on it. Ready? And any submission is welcome. Okay, repetitive submission, your submission about the same question are all welcome. All welcome. Okay. All right, go. How's it going? Anybody ready to submit? 6, 7, 8. Well, you may like to do 6, 8, and 7. I know there's a little bit more to do for number 7. So you may like to do 6, 8, 7. Yeah. Yay. Good. Very nice. Very, very nice. Okay. Thank you, Bailey. I see your message. Okay, so let me open it. Where's my canvas? Canvas is here. There, pronto. Oh no. Okay. Sorry about that. Click once should do it. All right. Wait, I clicked the wrong button. I clicked the wrong button. Well, it gets there. Okay, no worries. All right. Oh, this is fine. Okay. So look at this upload. So from right, so that's the next step, right? So from ln 3x minus 10 equals to 2, we get e squared equals to 3x minus 10. Adding 10 on both sides, divide by 3. Very good. Did you work on the domain and checking the work? So what's missing is, this is the solving part. Okay, this is the solving part. It's all good. It's all good. But what's missing is one is a domain before, and that's the check. I know sometimes we forget to do that, but we must. Okay, we must. Each part has answers and has points. Okay. Good job. Good job. Okay, but incomplete. Okay. Domain. Solving. And check. 3 parts for each of the questions. Because sometimes you may be surprised that the solution you found may not fit. Okay, may not fit the circumstances. Okay, that's why we must check. Okay, that's why we must check. Yeah. For domain, we will have 3x minus 10 is larger than 0, right? That's all we need to do, right? And then solving this inequality, we get x is larger than 10 over 3. Okay, so that's the domain. Solving it, I would just copy from Bailey's work, right? And he got it right. Okay. 3x minus 10 is equals to e squared. And then adding 10 on both sides. Okay, 3x equals to 10 plus e squared, or e squared plus 10, doesn't matter. And then x is equals to 10 plus e squared divided by 3. Oops, divided by 3. And there's a 10 right there. Okay. Is this in the domain? The first thing, of course, you look is domain check, right? But if you compare this number, obviously this number is larger than 10 over 3, right? So domain check, no problem. Right? This value is larger than 10 over 3. Right? You can see the numerator here, this is larger than the other one, therefore that's domain check is no problem. Okay, so let's check let's do the algebraic check. Right? Check this, you check the equation. Okay, check equation, you start from one side. Okay. One side. And you replace x by the solution we found here. Don't underestimate the benefit of doing these checking steps. If you do this, it will greatly enhance your algebraic skill. It will greatly, because you're going to encounter a lot of very interesting situations, and you get to practice quotient rule, product rule all over again. So these are very, very good for us. Very, very good for us. Okay, so don't, drop these two steps. I know we have the tendency to go straight to the solution. I did too. I do too. But we must be aware that the more we do this, the better you're going to be. Okay, so you can see this 3 and that 3 will be reduced. So you have 10 plus e squared and minus 10, right? That seems in this case, it works perfectly, doesn't it? And then equals to 2. Along the way, you are practicing your basic algebra. Okay, so along the way, you are practicing your basic algebra. Okay. And therefore, of course, we're going to draw the conclusion, and this is equals to the right-hand side. Right, the right-hand side is 2. Check equation. So we can say x, you can also make your sentence this way, right? Is a solution because the following steps. You can write it this way. This will save you a little writing. Okay, it will save you a little writing. Okay. But I do want to warn you before I see that mistake. I hope I don't see that mistake. Warning. Okay. Some people, when they check, they do this. Okay. They will put these number right here. And the next step, and this person will have 10 plus e squared. And then, and this student may do just ln e squared. Does that look familiar? Does that look like something you might do? Does that look like something you might do? Yeah. Well, this is something some student did before. Okay, this is something some student did before. And actually, it's in quite a lot of students did this kind of work. I will usually take 2 points off. I'm sure you don't like that. Okay, and this is a very common mistake. Let me tell you why I take this 2 points off. Okay, the fact that we are checking the answer is that you don't know if this is going to be true. We don't know. If we know, we don't need to check, don't we? So when we check the answer, we basically assume we don't know, or we don't know if this is true. So you should always start from one side. So logically, you should start from one side, not two sides at the same time. If you write it this way and you're telling the reader, hey, this is 2. And you tell the reader again, hey, this is 2. And hey, this is 2. Or 2 is 2. Don't do this. You commit a logical mistake. Do you follow me? That's why you can see I always do one side. It's more or less like when you prove identities in trigonometry, right? Can you do 2 sides at the same time? Absolutely not. If you do that, I will take points off. You know, I don't know. I don't care about what the other teacher will do, because logically you have committed a mistake. When you ask to prove something, you don't know that's true or not. You need to pretend it's not true yet. Because if you say this is true, then you don't need to tell me more. That's all I need to know, right? You don't need to tell me more about these. Do you follow me? So you need to have that logical pretending that you don't know it is true. So you start from one side and then you get to the other side. And then you say, hey, look, when I plug in this number, left will end up the same as right. That is the logic. Even though this is a minor mistake, and this is a very annoying mistake logically. A lot of students do this. But unfortunately, if you are in my class, it just doesn't, to me, it doesn't sound right. It doesn't look right. Therefore, I'll just take 2 points off. Okay, unless you have another argument that it can totally convince me that you do this and it's agreeable with mathematical grammar or with everything else. Okay, so please don't do that. Please don't do that. So I put this as a warning. I imagine there might be, you might have learned this somewhere else. Okay. But by mathematical grammar, this is telling the reader the left is the same as right. The left is the same as right. You're telling the reader 1, 2, 3, 4, 4 times. Redundancy. And illogical, because we want to demonstrate it is true. We don't know it is true. We pretend it's not true yet. That's why we went through the steps. Okay, so I hope that made myself clear repetitively here. And please do understand that you know, there's a logic behind what we do. Okay, so number 8, anybody want to submit? Number 8. Number 8. Anybody want to submit? Well, just a second, I'll be right back, okay? Oh, okay, I'll be right back, hold on. And more submissions are welcome, and I'll be right back, hold on.
You're muted. Professor, your mic is muted. Your mic is muted.
Professor, your mic is muted.
Sorry. Thank you.
It's okay.
All right. Missing parentheses. Thank you, Mikhail. I will get to yours. And you need these two parentheses. And now, and these steps are good. And so he got -25. He checked his work. So 2 minus -25, that's 27. Okay, you would like to write it this way. Okay, left is equals to, and this one will be continue equal. Sorry, put the equal sign here. Okay, equal here, and then you will say this piece, you say the right-hand side, because you just want to tell the reader left side is the same as the right side when this number is plugged in. And remove, just remove the whole thing. Okay, and over here, you write it equals to right-hand side. How about that? Got it? You don't need this line. I know you're tempted to try to write the 3, right? And you realize you shouldn't be doing that. No, just write left-hand side. So the point we are trying to make here is that you're telling the reader when I plug in this number, because remember, okay, let's recall the context. The context says if the left is the same as right, right? Do you follow me? Okay, so I'm gonna go back to our question. Okay, I want to explain to you the logic. Okay, I want to explain to you the logic. Okay, just give me time. Okay, so domain, he did a good job. So 2 minus x is larger than 0. Okay, as a result, x is less than 2. And when solve it, he got 2 minus x equals to 3 to the power of 3 definition. And he ended up with x equals to -25. Okay, and checking. Now, listen to the logic. Okay, the logical narrative. The logical narratives here. Okay, first, we know this statement is what kind of statement? It's an if statement. Okay, if the left is the same as right, and we're looking for, right, we want to find all solutions. Okay, so that's the context we start with. Now, we found a number now. We found a number. Okay, we go through the steps, whatever steps you do. Okay, we solved it. We solved and we found a number. And this number we found is x equals to -25. So what do we want to do? We wish to demonstrate that, okay, when this number, okay, when x equals to -25 is in the if statement. It is indeed true. Okay, because in this statement, it says if this is true. Do you guys follow me? So if this is true, because sometimes we say if something is true, you may not have a solution. Or you have some solution, but it doesn't fit the situation. Do you follow me? So you have to demonstrate to the reader saying, you know what, I found this number not only is in the domain, but it is also make the left-hand side exactly the same as the right-hand side. Therefore, it make the statement true. Do you follow me? Do you guys understand that logic? It's all because it's an if statement and we're trying to convince the reader the number we found indeed is or is not a solution. That's why we do it on one side, not both sides at the same time. Because if you do it at the same time, the first sentence you already told the reader, hey, they're the same. Do you follow me? You still need a few more steps to do the convincing. You basically show the reader, hey, look, if I put this on the left-hand side and I go through these steps and I get this number, and this number is the same as the number on the right. Therefore, when this number is plugged in, the left is the same as right. Did I make myself clear? Okay, so now, so when we check, besides the domain check, okay, the domain check, x equals -25 is in the domain. In the domain. Okay, because -25 is less than -2, right? And equation check. So the left-hand side equals 2, and this is a log base 3 of 2 minus -25. And then we end up, okay, so you basically carried out the operation to treat the reader as someone needs a lot of help to understand the work. Okay, so you show the reader, see, 2 minus -25 is 27, and log base 3 is 27 is 3, and 3 is the same as the right-hand side number, the number on the right-hand side. Okay, then you say thus, x equals to -3 is a solution to the equation. Do you follow me? In the whole process, we need to understand we have a coherent narrative. And in this narrative, logic has to be, logic has to prevail. Okay, and logic is the only thing we have to make sure it is, smoothly, logically arranged. Make sense? So don't do what I put for you in the warning. Don't do this. Just do one side and end it on the right side. I don't know what other teachers do. If you take my class and you do this, 2 points off automatically. because I have explained in class that's the logical flaw behind it. You follow me? If you recall what you learned in trigonometry, when someone asks you to prove a certain identity, do you do both at the same time? No. If you do that, if you take my class, you do that, you also lose probably not only 2 points, probably lose 5 points. That's a serious logical flaw, because when you ask to prove something, we have to pretend that something is not true yet. Otherwise, they wouldn't have asked you to prove it. Even though you in the end, you know it's going to be true, but you have to start with, you don't know it is true. That's why you start from one side. Okay, that's why you start from one side. You don't start with that, oh, left is the same as right. Left is the same as right. Keep going that way. That is never really, I would say, among all the teachers I know, okay, because you guys need to get points from certain professors, right? Professor at El Camino, professor at Cal State, professor at UCs and so on and so forth. So credit from your professor at USC, anywhere you want to transfer to. If you want to be on the safe side, you do what I told you. Okay. I don't know many people. I don't know anybody personally who would do this. But there might be somewhere out there, because I don't look at my colleague, how my colleague teaches, unless I'm required to observe their class. Okay, I don't peek at their work, but I know our student learn it from somewhere, right? So it's not entirely your fault. But when you present such work, and this kind of logic doesn't agree with a lot of professors, I know. So you're going to lose some point. So to be on the safe side, if you do it my way, I guarantee you're not going to run into any trouble. Would that be something you want? You want to present something that might be controversial? You want to present a way that's foolproof. Everybody has to agree. I will go with the latter, right? I would. It doesn't take too much more energy of mine. It's just a logical narrative, right? And understand the context. Okay, I'm saying this because I had to say this when I was teaching other classes at the point of identity proving identities for trigonometry. In this class, we actually didn't do a lot of identity proof. Okay, I kind of basically leave it to you. You always have to be aware. In your calculus class, you probably will have questions to prove something. When you are asked to prove something, you need to pretend you don't know that is true or not. Because of that, you don't do this kind of steps. You always start from one side. It could be starting from left, it could be starting from the right. Okay, so I have repeated myself so much. So let's move on to number 7. Number 7 is a little interesting, isn't it? Did anybody get your work done? Domain. So after these, we'll get to more complicated logarithm equations. Okay, so to determine domain, we're just going to say this must be greater than 0. Doesn't this inequality look like one of those in basic, what was it, basic 9? Right, solving inequalities, right? So you can do it in multiple different ways. So I would do it a short way. Right? So if this is true, this must be true. Oh, sorry, 1. Okay. And that is equivalent to, so I'm taking square root on both sides. So that's going to end me up at absolute value of x is larger than 1, right? You see, all of these, you end up with somewhere basic, right? Less than -1, or x is larger than 1. So that's the domain. Okay, that's the domain. And then we're going to solve the equation. We're going to solve the equation. Okay, so if this is true, okay, I'm going to put the if statement here just so you understand. This is the if statement. We are working with the if statement. Okay, and then what? Then x squared minus 1 equals what? E squared. Right? And then what? X squared is equals to 1 plus e squared. Okay? And you take square root on both sides. Oops. Ah, sorry. Take square root. Right? And you end up with absolute value of x equals to the square root of 1 plus e squared. And the solution, how many solutions do we have? We have 2 solutions, plus or minus square root of 1 plus e squared. Right? So you basically have 2 solutions, right? You have 2 solutions, x sub 1, but we need to check, right? We need to check. One is a negative of square root of 1 plus e squared, right? And the other one is x sub 2 equals to the positive one. Domain check. X1, this number is less than -1. Okay, so it's in domain. X2 is larger than +1. It is also in domain. Okay, you follow me? Okay, so basically, let's have a description of this domain. This domain is very interesting. Okay, so you
I
have
have
a
a question,
negative
Professor.
number. Sorry?
I have a question.
Yes.
When you have the x squared equals 1 plus e squared in the middle, can you just plug that into the equation?
Which one?
The x squared equals 1 plus e squared.
X
That part.
squared equals.
Can you just plug that into the original equation?
Which one? I'm sorry. Which one are you talking about? You're talking about this one
The one you just highlighted before in the middle,
here?
the one above it.
Here?
Yes,
To plug in where?
in the original equation where ln x squared is right there. Can you just plug that part in? And it
Plug in
equals,
where?
or I'll show you right now. I'll send you a picture.
Okay. Okay, so right now I'm showing you this domain, how the domain look like. Okay, our domain are these numbers. Okay, I'm gonna make it red. Okay, so these are the domains. Okay, so maybe I'll put some kind of notation here. Okay, not including yeah, I have some symbols I can use here. Here. It works, right? And over here, I'm going to use, so what I want to show you is the domain so it doesn't go away. You see that? It doesn't include a -1 and +1. So in between, so let me make this piece smaller, right? So that's a domain. That's a domain. Smaller than -1, larger than +1. So this number negative of √1 + e squared is in here. Is in here. And this √1 + e squared is larger than 1 is in here. So we have a solution in this piece and we have a solution in the other piece. Do you follow me? Okay, so did you send something to me? So he's going to send something to me. Okay, so we can just proceed until I receive that, and then we're going to talk about that. Okay. Thank you, Andy. Let's see what he got here. Andy. There. Okay, so that's what you meant. You get x squared equals e squared plus 1. This work you do is considered incomplete. Okay, it's incomplete because we want to know the value of x. You have only gotten the value of x squared. You follow me? So it's incomplete.
Okay, I got it. Yeah.
Right? So
Okay.
I don't see anything wrong from your work, but it's partially right. So this piece you have is, you just need to keep going to get what x should be. Okay? So you give us the answer for x squared. That's not what's being asked for. We're asking for x.
Yeah, I got it. Thank you.
Okay, no problem. Thank you for sharing. All right. So let me go back. Okay, so we're gonna go back to here. All right, so we got these two solutions and we're gonna check. Okay. I'm gonna show you two ways to check, especially inspired by Andy's work. Especially inspired by Andy's work. Okay, so I'm going to use Andy's work to show the check first. Okay, and you probably like this way better. You wouldn't like to see the other part. Okay. From here, when you check the equation, when you do the equation check, okay, you can actually start from here. Okay, and you can square both sides. When you square both sides, this is what you can do. You are going to get a 1 plus e squared. Do you follow me? And then you go to the left. When you check work, of course, you always have to go back to your original equation. We must go back to our original equation. So we will go back to our original equation. So our left-hand side, the x squared is equals to 1 plus e squared. And then, of course, you're going to get ln e squared And you're gonna have 2, and that is the same as the right-hand side. Okay. And then you can say, hey, x equals to, x equals to plus or minus, okay, are solutions. Okay, to the equation, right? To the equation, whatever it is, right? Of course, in our case, is x squared, and that equals to 2. You can do that way. Okay. And of course, the other way, you check one by one. You check one by one. But after you know this way, you probably don't want to do the check one by one, right? But I'm going to show you anyway. I'm going to show you anyway, because it's important to be able to do it, right? And this will greatly enhance your algebraic skills. Okay, so I'm going to show you, it's going to be quick. Okay, so you're going to say for x1, and then you go to the left-hand side, right? Which is ln, right? ln, so here you're going to have x squared minus 1, and your x squared is going to be what? It's going to be this guy. Okay, and you may want to put a bracket outside. Okay, and of course you're gonna get ln. You're gonna get ln because you square the -1 is positive. And you square root of 1 plus e squared is going to be 1 plus e squared minus 1, and that's going to be equals to 2, equals to right-hand side, right? And the same is true for the other one. So for this other one, the whole process can be redone all over again with the other value. And you also get it equals to right? So you're going to draw the same conclusion here. All right? Got it? But every answer has to be checked. Every claimed answer must be checked. Then you will see very soon that in the exercise we're about to do, some of those solutions are not fitting. Some of the solutions are fitting. And in some situations, you actually don't have any solutions. Okay, so without further ado, let's keep going. So we did all of these, fairly simple ones and not so simple ones. And next, I want to show you let's see which one do we do. Okay, next we're not gonna do one by one, but we're gonna do a lot of them. For example, okay, I'm gonna take you guys to do number 15. Okay, now I'm gonna choose. Okay, so this time I'm gonna choose 15. And you're gonna work with me. Log base 2, parentheses, x squared, oops, x squared minus x, minus x minus 2 is equals to 2. A lot of 2's in this question, right? Domain first. What is a domain? What is a domain? Well, x squared minus x minus 2 must be larger than 0. Right? And then we're going to solve this inequality. And solving by factoring, it looks like we can, factor it. And this is similar to a question in Alpha 9A, right? Yes, I think it's Alpha 9A. I got a little bit. If I'm wrong, just solving inequalities, solving quadratic inequalities, that part, okay? We're solving, where everything quadratic, we've seen something similar. But anyway, so what will be the solution? You can do the number line, you can do the graph, right? It should be pretty straightforward to you. But take advantage of this opportunity, treat it as a review opportunity. Do you know how to solve this inequality? So now you should understand why we call those exercise basics, right? Because we often encounter them. Right? Why we call them basics? We encounter them all the time, right? We can do the number line way, right? Like the sine of x plus 1. This is a kind of long way, right? This is a kind of long way, right? Remember what we did? Number line, -1, and that way. If you want to do it this way, I have no problem with it. Okay, just make sure you get it right. Okay. And the sine of what? X minus 2. So that's going to be positive 2. Okay. Remember that? And look at the signs, right? So this is going to, on this side, it's going to be -0, positive, right? For sine of, I should do it this way. Okay, put it here. And the next one. So this sign is going to be, this is a negative. Zero, positive. And then in the end, it's a sign of the product. Remember all of these? That's one way to do it. Whoops. The number line, -1. The number line continues. 2. Number line continues. Okay, so now we see that we're going to have a positive sign, right? 0. Negative sign, oops. 0. Negative sign here. 0. Positive sign. So what is the solution to that inequality? So the domain is what? Domain is what? X less than -1 or X larger than 2, right? Did you get that? I sometimes find the other way so much easier, which is the graph. Do you agree with me? Right? I can just graph this to determine domain. right? And I just do the graph. I know the x-intercept, right? X-intercept is found by the crossing with x-axis. You see, all that understanding is it just come to the picture when we need them, right? When we need them. Whoops. Okay. And then I just make some adjustment. For maybe this is going to be 5. This is a -5, +10, something like that, right? Something like that. And I understand that there's 2 points of intersection, and that's going to be circle, right? -1, 0. That's the intercept. So I put a circle there, and there's another one, 2, 0. So these are the points of intersection, and then my domain would be the domain will be here, right? To make it positive, right? Because this is the positive piece, positive piece, positive piece, negative piece, right? The output positive, output positive, output negative, output 0, output 0. You see, input, output. Right? So that function perspective really is very, very powerful. And did I tell you this? I was telling you in the beginning of the semester, I tell you the theme of this semester is function. Are we still in that theme? Yes, absolutely. Not for a moment. I want you to take away, I want to take you guys away from that theme. Okay, very powerful theme and very powerful definition. Okay, the entire semester we're working on that definition. Okay, so without further ado, you can also demonstrate to the reader, because you not only show it to yourself, you also show your reader. Because most of the time you're doing this academic work, you want to be graded, you want to be assessed, you want to get an A, right? Therefore, and you mark your grades. So this is how you show your work, okay? If you show by picture, okay, if you show by picture, then you want to show clearly. Okay, you want to show clearly. The domain. It doesn't matter how you show it. You can just put a bunch of you can show a bunch of symbols if your favorite symbols, or you can just show like what I showed here, right? With circles and graphs to help you to convey the same information in different ways possibly, and without ambiguity, Okay, so anyway, for me, this is sufficient. So you can tell the reader, right? The domain, right, is x less than -1, or x is larger than 2. I like it this way because it's so clear. It's so clear, right? Can you do it that way? Of course. Why not? Why not? But anyway, we just did the first part. The second part, solve. Right? So what are we solving? This guy is solving. It's an if statement, right? If this is true, okay? By definition, x squared minus x minus 2 equals to 2 squared. okay? And then this seemed to be a quadratic equation. 2 squared is 4, subtract 4 on both sides, so we have 6. Factor. Did you see quadratic function is so commonly used in academic setting? Do you guys see that? Right? So we got the solutions. We got the solutions to the quadratic equation. Okay? And then what? Domain check. I kind of skipped a step. Okay, I can skip a step. But I don't think you mind, but I want to just put it there. Okay? Okay, domain check. Are they in the domain? So what is the domain? Less than -2 or larger than 2? Well, -2 is less than -1. So that is in the domain, right? This is less than -2, less than -1, therefore it's in domain, right? And the other number, x equals to 3, is larger than 2, therefore it's in domain. So when I'm writing this down, what am I quoting? I'm quoting the domain. I'm quoting the domain. That's a domain. That's a domain. You follow me? Yes? I'm quoting the domain. Domain is in my mind. And further check, okay? For this time, you have to combine them. You have to separate them. I'm sorry, you cannot combine them. You have to separate them, right? So for x equals to -2, you go to the left. Okay, and the left is this guy. You should replace x by -2. And this is -2. Equals to log base 2 of -2 squared is a 4, right? 4 plus 2 minus 2, right? Minus -2 is +2. So over here, you have log base 2 of 4, which is going to equal to 2. And that is equals to the right-hand side. Right? So you can say x equals -2 is a solution because, right? The next part, similar. X equals to 3. And you just plug in 3. Plug in 3. Okay, so this is 9 minus 3. Okay. Minus 3. And so this is going to be 4, 2. Yeah. Same thing. So that's how you check. You have to check one by one. In this case, both number we found are solutions. Both number we found are solutions. So far, we have not encountered numbers that is not a solution, right? And we will tomorrow. So I encourage you guys to try the rest of those exercises. And I think you should have enough tools to do all of them right now. So try as many as possible. And tomorrow we're going to practice a lot. We're going to exercise together. So we're going to do a lot of exercise, following these steps. And guess what? at the end, you're gonna be so good. You're gonna be so good at this. Okay. Do you have any other questions? So very good job. Okay, very good job. And I especially appreciate the submission of your work in class. And I wish to get more of your work in your class from the class. And you should be expecting 2 quizzes and for this week. Tomorrow, the last day of this week. All right, I will see you guys. I'll see you guys tomorrow. I'm looking forward to it. And I will be in my office hours at 40, okay? 9:40. Okay, have a great day.
Thank you.
Thank you.